In this video, we will explore the fundamental operations in relational algebra. These operations form the basis of SQL queries and are essential for manipulating data in relational databases. These operations include select, project, union, intersection, and difference. The select operation, denoted by the sigma symbol, filters rows from a relation based on a specified condition. It is a unary operation, meaning it operates on a single relation, and it produces a horizontal subset of that relation. Only the rows that satisfy the given condition are included in the result. For example, consider an employee relation with attributes like ID, name, department, and salary. If we apply the select operation with the condition department equals IT, it will return only the rows where the department is IT. In the example, we select from the employee relation where department equals IT. The result includes only Bob and Carol, who belong to the IT department. The project operation, denoted by the pi symbol, extracts specific columns from a relation, creating a vertical subset. It is also a unary operation, meaning it operates on a single relation. The project operation removes unwanted attributes and eliminates duplicate tuples in the result. For example, if we project the employee relation onto the name and department attributes, it will return only these two columns for all employees, removing any duplicate combinations. In the example, we project the employee relation on the name and department attributes. The result includes only the name and department columns, with no duplicate rows. The union operation, denoted by the union symbol, combines tuples from two relations, removing any duplicates. It is a binary operation, meaning it operates on two relations. For the union operation to be valid, both relations must be union compatible, meaning they have the same number of attributes with compatible domains. Duplicates are automatically eliminated in the result. For example, if we have two relations, Department A employees and Department B employees, the union operation will combine the tuples from both relations into a single relation, removing any duplicate employee entries. In the example, we take the union of Department A employees and Department B employees. The result includes all employees from both departments, with no duplicate rows. The intersection operation, denoted by the intersection symbol, returns only the tuples that appear in both relations. It is a binary operation that requires both relations to be union compatible, meaning they have the same number of attributes with compatible domains. The result contains only the tuples that are present in both input relations. For example, if we have two relations, Department A employees and Department B employees, the intersection operation will return only the employees who are present in both departments. In the example, we find the intersection of Department A employees and Department B employees. The result includes only Brown, who is present in both departments. The difference operation, denoted by the minus symbol, returns tuples that appear in the first relation but not in the second. It is a binary operation that requires both relations to be union compatible, meaning they have the same number of attributes with compatible domains. The difference operation is not commutative, meaning A minus B is not equal to B minus A. For example, if we have two relations, Department A employees and Department B employees, the difference operation Department A employees minus Department B employees will return the employees who are in Department A but not in Department B. In the example, we find the difference between Department A employees and Department B employees. The result includes Smith and Jones, who are present in Department A but not in Department B. Relational operations can be combined to form complex queries, similar to how SQL queries are constructed. For example, we can combine the select and project operations to find the names of employees in the IT department. First, we select the IT employees and then we project only the name column. Another example is to find all departments with employees earning greater than $70,000 or less than $50,000. We project the department from the selection of employees whose salary is greater than $70,000 and take its union with projection of department from the selection of employees whose salary is less than $50,000. relational algebra operations map directly to SQL constructs. The select operation is equivalent to the where clause in SQL. The project operation is equivalent to the select clause in SQL. The union operation is equivalent to the union operator in SQL. The intersection operation is equivalent to the intersect operator in SQL. For example, the relational algebra expression select department equals IT from the employee relation is equivalent to the SQL query select asterisk from employee where department equals IT. Similarly, the relational algebra expression project name and salary from the employee relation is equivalent to the SQL query select name, salary from employee. To summarize, the select operation filters rows from a relation based on a specified condition, creating a horizontal subset. The project operation extracts specific columns from a relation, removing duplicates, creating a vertical subset. The union operation combines tuples from two union-compatible relations, removing duplicates, requiring relations with the same schema structure. The intersection operation returns only tuples that appear in both relations, requiring union-compatible relations. The difference operation returns tuples that appear in the first relation but not in the second, and is not commutative. These operations can be combined to form complex queries, similar to SQL, and they form the theoretical foundation of relational databases. These fundamental operations form the basis of relational database query languages and are directly implemented in SQL. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.